Okay, and why do we do all that? Separation of layers. So this is different layers, and these layers exist for a good reason. So there's a reason why we have these separate layers in a database. And the reason is to ensure that database can implement their goals. And these are some of the most important goals of databases, some of which we have already written down before. But let's briefly go through them and see how the database ensures that we can that we have those goals implemented. So first, we want to query the data. That's something naturally. If you store data, we want to somehow be able to query it. By querying, I simply mean, okay, I want to get data out of the database and do something with it. So we usually apply in relational databases, we use SQL as the means to do that. And examples are, we want to select certain rows and columns. We want to maybe aggregate the data. We want to calculate something based on the data, or we want to filter that data. So that's SQL, and that's one very important part of a database. And how is it achieved? Well, this is done or this is achieved by using SQL as an independent means to query databases. And it's achieved by using or by having the database management system sitting on top of the actual data pool and translating the queries in SQL into a language that in the lowest level the database knows which files it needs to access in order to process a certain SQL statement. So it goes through all the layers, and the SQL statement is basically translated into, okay, which files do I need to open and what data from those files do I need in order to answer the SQL query. And why do we need SQL as an independent language to query data across different databases? Well, one reason would be, what if I have an application? Let's say I have an ERP system. Everyone knows what an ERP system is. Enterprise Resource Planning is basically a big information system where companies store a lot of information, master data about products, production, bill of materials, sometimes customers, sales. So almost everything that is relevant to the business of a company is stored in an ERP system. And so the idea is to separate the ERP system from the database, and we have this interface between the graphical user interface and the business logic and the database using SQL. So we can simply say, okay, there's an interface SQL which is independent, and that means we can exchange the database. So for example, we could say, okay, we want to use Oracle database to start with, and then later on, maybe in 10 years, Oracle is not that appealing anymore to us, and there's a new database, it's much cheaper, and can we exchange that database? So the question is then, okay, if we exchange the database, will our processes on top of the database still be able to work? And the answer is yes, with an asterisk, so with some limitations, but basically yes, because we use an independent way to have these two layers talk to each other. It's SQL. Okay, so managed data is basically just another example of what we can do with SQL. We can not only query the data, we can create data, we can read data, we can update data and delete data, which makes up the 4 so-called Crud operations. That's here in parentheses. So Crud operations is basically adding new data, reading data, changing existing data, and deleting data. And all these operations should be possible and are possible with SQL, and this is something every database should allow us to do. So the very important aspect, and we have it here under databases are safer to work with, are data integrity, or is data integrity. So we want to make sure that our data in the database is consistent, non-redundant, and complete and correct. And if we use Excel and anyone can change everything, there's no way how we can ensure that. So how does a database ensure that? Well, we will learn about the relational model in a second. And one of the most important goals of the relational model is to ensure data integrity on a database level. All right, encapsulation, hide complexity and simplify access. We do that using views. So we have a large data model, and maybe you have opened a very complicated Excel spreadsheet before, where you have maybe 40 different sheets. It's very complicated, and you need to understand where to open what. And if you only need one certain aspect of the data, it's very hard to find that. In databases, the concept of views allows us to give a user exactly the view on the data that he or she needs, only with that data included that is relevant to him or to her. And we use views for that, and this allows us to make it less complex. So we can have a very complex database, but we can ensure that everyone can access it very easily and with little effort. Yeah, and then we have the multi-user access to the data, which is basically what databases ensure using transactions. So you can read and write the same data simultaneously. So imagine you have an ERP system and you are a global company. Then you might have many users using their laptops or their desktop PCs accessing the same, let's say, customer record. So they all open up, I don't know, 3 people at the same time open up a customer record because for whatever reason they need it. And then somebody enters a new value into a field, and another one does, and they leave it open, and they go to the phone, and then after a while they hit save. So that's basically how ERP systems work. At some point you would say, okay, save this record. So what could happen if 2 people hit save and one does it earlier than the other one? At the time that one person hits save, the data mask of the other person is basically outdated. So because something has changed in the background and the data they see is no longer valid. So when we would use Excel for that, there's no way to ensure which transaction, as we call it, or which user will win the competition of entering data. So what happens in a database is we have a transaction, and either that transaction is completed or that transaction fails. And in this case, depending on how we configure the transaction order, the person that has the screen open and wants to hit save later on with the outdated data will get a message, okay, your data cannot be sent to the database or cannot be saved in the database because we have a conflict and another user has submitted a change in the meantime, and you need to refresh and then you can make your changes. So that's a way how you could ensure that the data stays consistent and not multiple changes happen at the same time with outdated data. So that's one way how databases do it, using transactions. So there's of course different ways how a user could handle that, but the important thing is that we make sure that we have a transaction, a consistent data, or that we have consistent data in our databases, and not a mix of different changes that do not consistently fit together. All right, and last but not least, protect the data in the sense that we have only authorized clients or only authorized staff that can access the data, and we can even say, okay, people from the company who work in a certain department can access the sales data, but others who work in the production, they cannot access sales data. So we can say there are different roles. One has the role salesperson, the other has the role production staff, and they have different rights to access the data. And we can do that on table level. So we can say certain tables are out of reach for certain people. We can do it on column level. We could do it on row level. So we have very fine-grained tools to protect the data and have only the people access the data who are really authorized to do so. And the means how we do that, or how databases achieve this, is through users. So you have the concept of a user in a database, you have user rights, and you have roles, for example. So these are the main goals. I wouldn't say these are all the goals, but these are the most important aspects that databases offer us, or functionalities that databases offer us. And on the right, you see the means how they achieve that. So another one that just came to my mind, because we have this part large data sets and also unstructured data, is scalability. So databases should be scalable in the sense that when I run out of disk space, I can add more disk space or more servers, and the database can be expanded horizontally, so I can add more hardware and store more data. It should be possible to do that. Excel, on the other hand, and I always compare it to Excel because that's usually what most of you know and have used before, or even Access has this limitation. So basically local tools that only work on our laptop. If we have an Excel file and we run out of space, it becomes too large. There's really no way how we could scale Excel any more than saving one large file. And if our computer's hardware and hard disk isn't big enough to store that file, well, then we still need another computer, but then we are no longer on our laptop. Then we are also in a server environment, and Excel doesn't offer any way to scale on a server and have scalability features incorporated in their product. So that's a hard limitation that we hit here.